Hi, kiddos. It's Miss Richmond. This is week 4 of our distance learning for chemistry at DCP. Right now, you're looking at your COVID-19 closure assignments document. This is the one where literally all of your assignments are going to be posted for the entirety of the closure. I changed around the formatting just a little bit. So now all of your previous assignments are going to be listed down here. So like, here's what we did the very first week, right? Here's what we did the second week. Here's what we did last week, week 3, and it tells you the dates. And then here is what we're working on for this week's assignments. So for this week, we're going to be continuing to work on stoichiometry. I expect that that's what we'll be working on for the entirety of the school closure, depending on how long it lasts. Oh, my hair. So when we were back at school, some of my classes, I'm not sure if all of my classes, I'm positive that first period, a couple groups got started on this, maybe all of the class, and maybe some of my other classes, we were getting started on this stoichiometry POGL. So what we're going to do for this week's assignment is work on model 1 from this stoichiometry POGL. So I basically made it into a separate document, which is here so that you guys can edit it, but it's pulled pretty much directly from this POGL. Okay, so this is what you're going to be working on this week is this mole to mole conversions, which is a part of stoichiometry, right? Stoichiometry is all about converting different quantities of matter in a balanced chemical reaction, figuring out, if I have this much of H2O that I want to produce, how much hydrogen gas am I going to need? How much oxygen gas am I going to need? That type of thing. So for this week, we're going to be starting pretty basic, and we're doing just mole to mole conversions. So if I have this many moles of nitrogen gas, how many moles of ammonia gas am I going to produce? NH3, right? And that's actually this equation that's down here, this example. So the instructions for this assignment, watch this video, which you're already doing if you're seeing me explain this, right? So watch this video to see me explain the assignment and work through the first 2 problems. And then you'll complete the remaining problems on your own. It's only a 2-page document, so it's not anything crazy, and then complete it on your own. Make sure to click turn in on Google Classroom once you finish the assignment. I haven't posted this on Classroom yet, but I will, and it's just called multiple conversions. It should be at the top of your Google Classroom. So in terms of background, again, I pulled this directly from the stoichiometry POGL. Chemists use balanced chemical equations as a basis to calculate how much reactant is needed or product is formed in a reaction. This is called stoichiometry, and they tell you how to pronounce it. Stoichiometry. Students always struggle with that. Another way of looking at it is using the mole ratio, which we'll talk about, from the balanced chemical equation and information about one compound in the reaction to determine information about another compound in the equation. That's a lot of words, very complicated sounding. We are still doing conversion factor problems just like what we've been doing. We still have our same 4 steps, right? Determining our given value and our desired unit, all of this stuff that we've been doing, only now we're using balanced chemical equations to do it. And then it says, we're on this sentence, a mole ratio is a conversion factor derived from the coefficients of a balanced chemical equation interpreted in terms of moles. In chemical calculations, mole ratios are used to convert between moles of one thing and moles of another. So here's an example that they give you, and they actually are showing you how to solve this. So we're going to answer these couple questions about it, and then I want to do one example from this different chemical equation, okay? So in this example, we're doing a mole-to-mole conversion. So the question is, given the following equation, 1N2G, which is gas, plus 3H2, also a gas, yields or produces 2NH3, also a gas. We actually know this equation, right? This is the one to form ammonia gas. We've looked at this quite a few times. It's where we take nitrogen gas and hydrogen gas to form ammonia gas. That was the one that was used in World War I, World War II. Mr. Blanco, Ms. Velez, Mr. J, can someone watch this video and tell me? But yeah, it was used to make like explosives in one of our world wars. And then the actual question is here, and it says, hold on, let me do this. How many moles of H2 are needed to produce 34.8 moles of NH3? How many moles of H2 are needed to produce 34.8 moles of NH3? And then it shows you how they solve it. So here's the answer. Just like what we normally do, they take the given, right? 34.8 moles of NH3. They take that given and put it here. We usually put that over 1. They just kind of left it by itself. But I would normally put that over 1. And then they use the mole ratio, and we'll talk about where we can get that. And then they just solve just like we normally do. So they did 34.8 and then multiplied across the top times 3 and divided across the bottom, divided by 2. Plugged that into their calculator and got this answer, 52.2 moles of H2. And then they just showed you literally the exact same way to solve it, just like they wrote it differently in this one. So now we're going to answer some questions about this problem. First question, and I want you guys to have this document open while you're like watching me explain this video. So if you need to pause this, take a second, go to your Google Classroom, open the multiple conversions document so that you can be following along and working on this with me in real time. So first question, what's the given in the example above? So this, remember, is our question. How many moles of H2 are needed to produce 34.8 moles of NH3? So what are we given in this problem? We're only given one value, right? And it's 34.8 mole, and that's of NH3. And you guys can just type this. And if you end up typing and you write NH3 like this, NH3, I'll know what you're talking about, right? So don't worry, don't stress too much about like the subscripts and all that stuff. So this is what we're given, 34.8 moles of NH3. Next question, where did the mole ratio, this 3 mole H2 over 2 mole NH3, where did that come from? That's this number, or this, oh my gosh, what the heck? Oh, there we go. That's this little ratio that's right here, right? This conversion factor that we ended up using. Where did that come from? So 3 mole H2 over 2 mole NH3. I want us to go back to our balanced chemical equation and think about where that might have come from. 3 mole H2 over 2 mole NH3. So let's find H2. And we notice that there's a 3 out in front of it, right? So that's where that 3 mole H2 comes from. And then if we find NH3 in our balanced chemical equation, same idea, right? 2 is that coefficient, that number out in front of NH3. So where did that mole ratio come from? It's basically the coefficients, right, from our balanced chemical reaction. So there are 3 mole of H2 in the balanced chemical equation. The 3 is the coefficient on H2. I'm kind of being wordy here, but you can definitely write this in your own words. There are 2 mole and H3 in the balanced chemical equation. The 2 is the coefficient on NH3. And this really bothers me, but again, I don't really care if you fix it, but I'm just gonna fix these subscripts really quick. I just don't like the way that it looks. Okay, so that's my answer for this question. You can write something similar or change the wording or whatever it is. Okay, now we're gonna actually double check to see if 52.2 moles of H2 is the correct answer, and we'll show our math below. So I'm gonna actually pull up my, my steps again to solve any conversion factor problem. Where should I put myself? Here we go, I'll go down here. And I'm going to work through these steps to do this conversion factor problem, just like we would do any conversion factor problem. Okay, so step 1, determine given value and desired unit. So I'm going to go back to my question. How many moles of H2 are needed to produce 34.8 moles of NH3? My given is 34.8 moles NH3. Desired unit, I'll just put desired actually. Desired is mole H2, right? That's what I'm trying to figure out. Oh, I did not mean to do that. I just meant to do, there we go. Okay, so we've done step 1. We know what the given is and what the desired is. Sorry, my dog's like staring at me over the camera right now. Here she is, in case you're interested. Anyway, sidebar. Step 2 is draw the map and use the conversion factor to kind of show how you're going to go from your given to your desired. So I'm actually going to draw this out. And I want you guys to either show your work, or what I've written down here is write your work on a separate sheet of paper and upload the image. That works for me too, because I don't know what software you guys can do where you can like draw on this. Actually, maybe you could do insert drawing and do it somehow like that. But I'll leave that up to you guys to kind of try and figure out. Okay, so I'm going to draw my map using the conversion factor. So my given is 34.8 mole MOL NH3, and we're going to mole of H2. And our conversion factor, the thing that we're going to write over the arrow, is how NH3 and H2 are related. So we have to go to our balanced chemical equation to figure that out. So I'm going to get some different colors. Let's do like a green maybe. So we're comparing moles of NH3 to moles of H2. So for every 2 moles of NH3, there are, what color should I do now? Orange. There are 3 moles of H2. That kind of looks ugly. Let me try again. There are 3 moles of H2. So that's how they're related, right? Is those 2 coefficients. So I'm going to just put that as my conversion factor on top of the arrow. We always are going to do just like this equals this, right? So 2 NH3. Sorry, it's really hard to write on my computer. That kind of looks like a 1. It's supposed to be a 2. 2. Is that better or worse? I don't know. That equals 3 mole of H2. 3 H2. All right, now we're ready to solve. Oops. We're going to start by putting, I don't really need anything from up there anymore. All I need is this. We're going to start by putting our given over 1. I'm going to see if I can, nah, actually I won't. We're going to start by putting our given over 1, 34.8 moles. Over 1. We only have one conversion factor, and we're going to convert using desired over given. Since our desired is moles of H2, I'm going to put 3 H2 on top. Technically, we should be writing 3 moles of H2, but I'm not being super particular here because it's really hard to write. And then our given is moles of NH3, so we're going to put that 2 NH3 on the bottom. And that's our green one. We just recolor code this. H3. 3 H2. Now we're ready to solve. Same as above. Multiply across the top, divide across the bottom. So we'll do 34.8 times 3 divided by 1 divided by 2, and let me get my calculator. 34.8 times, what was it? Times 3 divided by 1 divided by 2. And that gives us 52.2, which, double check to see if 52.2 is the correct answer. So it looks like either we did something right or they did something right, or both. I think it's both. 52.2 mole of H2. You guys know I love it when you box your answers. If it's possible, do it. If not, it's not possible. If we were doing this all handwritten, if we were, in real life learning, I would definitely make you guys box your answers. All right, so we did this whole first set together. I want to do one practice problem from down here as well, and then you guys will do 6, 7, and 8 on your own. So let me just erase all this junk up here, and then we will do number 1 on this one together. All right, so in this one, we're given a different balanced chemical equation. We're given 4P plus 5O2 yields or produces, right, 2 P2O5. So what that means is 4 moles of phosphorus, P, plus 5 moles of oxygen gas, O2, yields 2 moles of P2O5. I don't even know what that is. Diphosphorus pentoxide. I don't know what that is. Like, I don't know what it actually is in terms of like what the chemical is. Let's see if we can find out. P2O5 is phosphorus pentoxide. Okay. Really not telling me much here, but whatever. That's what I thought it was. Okay. Our first question here is how many moles of P2O5 are formed from 3.4 moles of O2? And again, we want to show the math or write our work on a separate sheet of paper and upload the image. Honestly, I think that's probably going to be the easiest thing for you guys to do. If you want to just show all your work on one page and upload it all at the bottom, that's totally fine. But somewhere where you're, showing me how you got what you got, right? Okay. So same steps as above. I'm going to do these 4 steps right here. Determine my given value, draw my map, put the given over 1, and convert using desired over given. Same as any conversion factor problem. So first step, I'm going to determine my given value and desired unit. So my given in this question, how many moles of P2O5 are formed from 3.4 moles of O2? So 3.4 mole O2 is my given, and my desired, trying to figure out how many moles of P2O5 are going to be formed from that, right? Okay, draw our map using the conversion factor. So we're going to go from 3.4 mole O2, and we're trying to get to our desired, which is mole P2O5. And we need to figure out how are those things related. So again, we're going to go to our balanced chemical equation and figure out what is the mole ratio there, right? We're comparing moles of O2 and moles of P2O5. I'm going to, again, pick colors for each. Let's say moles O2 is blue and moles of P2O5 is red. So I'm going to underline my P2O5 in my balanced chemical equation, and I'll underline my O2 in my balanced chemical equation. And then from there, it's pretty easy to see, right, how they're related. So for every 5 mole O2, because we have 5 as our coefficient here, that equals 2 mole of P2O5, because 2 is our coefficient here. Again, I'm just going to fix these little subscripts, and then I will be ready to solve. I'm going to color code here again, because why not? Ooh, that's impossible to see, isn't it? Let's do the text color instead. 5 mole O2 equals 2 mole P2O5. Okay. Now we are ready to solve. First step, best step, right? Take our given and put that over 1. So I'm trying to pick a color that I haven't used in this problem. Take our given and put it over 1. So we're going to do 3.4 mole O2 and just put that over 1. The best step, the easiest step. And then convert using our conversion factor. And we're going to put it in the format of desired over given, right? So I only have one conversion factor, so I just need one set of wonky, ugly parentheses. And we want our desired over our given. Our desired, right, is P2O5, so we want that on top. 2 mole P2O5. And our given is O2, so we want that on the bottom. 5 mole O2. Ooh, it's a little funky. And now we are ready to solve. All I have to do, same thing, multiply across the top, divide across the bottom. 3.4 times 2 over 1 over 5. And let's plug that into our calculator. Calculator. You can use the app too, but this, for whatever reason, feels easier. So it's 3.4, what was it, times 2 divided by 1 divided by 5. 1.36 is our answer. And the unit for that, remember what we're solving for, is moles of P2O5. So 1.36 mole P2O5. Ooh, and again, I'm going to box that answer. Okay. So that is what you're doing. You have 3 problems left to work through on your own. They're all multimole conversions just like that, all using this same balanced chemical equation here, just comparing different reactants and products and using different numbers. So work through this, use your conversion factor little steps that are right here. Text me if you have any questions. You guys should know how to get in contact with me, but if you don't, it's all on the chemistry COVID-19 closure assignments document. So you can see, again, what my office hours are, my email address, my phone number, and my Instagram. All of those are ways that you can contact me. Let me know if you have any questions. And you have spring break next week. So definitely use this time to get caught up and email me as you're catching up on Khan Academy assignments. It doesn't update me or send me an email to say, hey, this student turned in this assignment late. So I would have to go through and check every single one. It's easier if you just email me or text me and tell me, hey, I finished my work. Can you update my grade? And spend next week relaxing, catching up on work, spending time with family, doing self-care, all of that stuff. Love you guys a lot. Let me know if you have any questions. Bye.